before we jump in, guys, it's gonna be a fun one. Do me a favor, hit that thumbs up button, and please subscribe. It'll help me grow the channel. Appreciate it. Let's jump right in. What's going on, guys? IT Unicorn here. Today we want to take a look at switching loops and spanning tree protocol. So to describe what a switching loop is, I've put together a PowerPoint presentation slideshow. So we have 3 switches interconnected here, and we're going to walk through and talk through how a switching loop gets formed or how it happens. And then we'll open up GNS3 and lab it up, and we can talk about how to prevent switching loops, and we can even take a look at a switching loop from the switch's perspective, and maybe even break open Wireshark and look at some of the packets that loop through the network. So without further ado, let's jump into the PowerPoint presentation. So again, we've got 3 switches there, all interconnected. So what happens when PC1 sends out a packet? It's a broadcast packet. What happens with a broadcast packet by default? We talked about this in other videos. By default, a switch will forward a broadcast packet or broadcast it out of all links on the same VLAN, or interfaces I should say, except for the one it learned it on. So when switch 3 learns or receives the broadcast packet from the PC, by default it's going to forward that out the 2 other interfaces on which it did not learn that MAC address or did not receive it from, in other words. Okay, so switch 3 then sends it over to switch 4 and 5. Switch 5 receives it. He's going to forward it out to switch 4. Switch 4 receives it. He's going to forward it out to switch 5. So we can already see we've got a packet kind of going in a circle here, right? Switch 4 will also forward it down to PC2, because again, any interface on which it did not learn about it on, it's going to forward it out. Okay, so after that, switch 4 is then going to send the packet that it got from switch 5 back over to switch 3. So there you go, you've already got a little loop action going, right? And then switch 5 is going to do the same thing with the packet that he received from switch 4. So I've numerically labeled these, right? So this is kind of like a sequential data flow of packets here. And this can go on and on. I just stopped it at 5 because you can see now we literally have a circle. And this is going to keep going and going and going. This is bad for the network, causes congestion. It also causes inconsistent MAC tables, or like flapping of the MAC tables, the MAC address or the CAM tables. So for instance, switch 3 learned PC1's MAC address on this interface. So his CAM table now says, hey, fast13 is where I can find the MAC address for PC1. But what happened when this packet came back over through this loop, so sequential 4 here, now he's getting that same broadcast packet on fast11. So the MAC address table is changing where he knows that. And then what happens over here? He's getting the same packet from switch 5, which is coming in on fast12. So that CAM table is going to get real messy. It's going to be, you know, flapping, so to speak. And this will go on forever because these broadcast packets on layer 2 don't have a TTL value like ICMP or layer 3. Routing has that built in, so it'll have a default TTL or time to live. So after each hop, it'll decrement down and it'll reach 0 to prevent routing loops. That doesn't happen with switching, guys. So that's where we have to take a look at spanning tree, which is the mechanism that helps us avoid that. So let's crack open GNS3. Give me 1 second here, guys. All right, guys, so now we're in GNS3. I just set up a very basic lab here. I've added 3 ether, they call them ether switch routers, multi-layer switches. Essentially in GNS3 it's just routers with a ether switch module, so you can treat them like they are switch ports, so you can do layer 2 switching. So this is, just think of it as one big broadcast domain. All these ports on all the different switches are on VLAN 10. I just created a VLAN. And then the access port here for the PCs are also on VLAN 10. There's no IPing on the switches. Again, broadcast domain. So these guys are just configured. These are VPCs. You don't know how to set them up. You just drag a VPC over. I've got a whole video on it. It's only 5 minutes. Very useful to know how to do if you use GNS3.
But essentially I just give them an IP address and not even a default gateway, just an IP and a subnet mask. Because again, they're just going to broadcast their way over to each other. So the way it sits right now, there should be connectivity between PC 1 and 2. I did a lot of this ahead of time, so I didn't bore you with the configuration. So yeah, PC 1 can ping over to PC 2, no problem. So by default, when you set this up, spanning tree is going to be active, and that's going to prevent a switching loop. So let me show you what I'm talking about there. I'll bring up switch 1, 2, and 3. And I've already done a show spanning tree VLAN 10 brief on all three. And what we're looking at is the ports here, right? So this is going to show you all the ports that are connected on VLAN 10, and they're all in a status of forwarding. So to prevent a loop, we need to block in this triangle one port. So nothing can do a full circle, in other words, right? So one port has to be in a blocking state. Now, from a physical standpoint, the port is active. It's not going to show down or amber or red or anything like that. It's green, the port is physically up. It's just going to block on VLAN 10. This is per VLAN spanning tree protocol. So we're going to do same thing here, and we see on switch 2, which is this guy, he has 2 ports connected on VLAN 10. They're both in a forwarding state. Now here on switch 3 is where we see the one blocked port. So fast 1.1 is blocked. As you can see, the physical interface is up, but if this guy tries to broadcast out on VLAN 10, it's going to be blocked. That's why the connectivity is working right now. If we go ahead and do a simple no spanning tree VLAN 10 on all these, never do this in production, by the way. You get in trouble. Oh, we gotta get in config mode. Okay, we just created a loop. So now let's try to ping. Not gonna work because the packets are growing crazy. It's gonna be inconsistent, right? And I bet you we have a lot of congestion on here. So we looked at our memory resources, things like that. Now it says not reachable. So what's happening, like I showed you that diagram, right, in that PowerPoint presentation, these frames, this layer 2, so technically they're frames. I use the term packet a lot. These frames are just looping through this network, and those MAC tables, those MAC address tables or CAM tables are just going crazy. So he thinks PC1, the switches think PC1's MAC address is, you know, coming from one interface and it's flipping to another, and it's coming, they're so confused, they don't know what the hell's going on. So if we run another ping and we start a capture here, we should be able to see that there's quite a bit going on. So actually, let's not do it on that interface. Oh, never mind. We don't have any spanning tree, so it won't matter what interface, that's fine. Where's my capture? Where'd it go? That's cool set. Let's try again. Bear with me, folks. Here we go. Okay, so let's try that ping again. I think we can do an extended ping command with a BPC. You guys all know how to set up BPCs. Like I said, check out my video on that. PC1. We can do ping-c for count. Okay, ping-c 100, 10.10.10.2. No, maybe we have to do this first. 10.10.10.2-c 100. There we go. This is going to try to send 100 packets. And this thing is going to go around and around and around and around and around and around and around. And if we look at another link, it's literally going to be the same packet that's looping around and around and around and around and around. We can stop this. So as you see, guys, I've stopped the ping and we only set maybe 10 or so, and this is still going. That's because those frames are just looping around the network like crazy, right? And now these switches are going to become very angry here if we let this keep going. So if we do show memory, processor, statistics, I think. It might not even be able to produce the, yeah, there it is, okay. Allocating process. So we haven't killed the switch yet, but it's not going to be happy here shortly. And this is just one PC sending out a ping, right? Well, let's see if we can ping. Nope. So I hope this is helpful, guys, to kind of visualize what a switching loop is. Again, these packets are not only going this way, right? Remember, when this guy receives it, he's going to send it back that way, and so on and so forth. So we've got packets going back and forth both ways. So you've got like this nasty, gnarly whirlpool in two directions. It's not ever going to stop until you configure spanning tree again. So how can we fix it? Well, let's just turn spanning tree on. So all you do, spanning tree, VLAN 10. Just do the same thing over here. And same thing on switch 3. And it should quiet down fairly quickly here, guys. Let's see if we can ping. Spanning tree does take a minute to actually go through its algorithm and decide what to block and what not to block. So let's give this a second here, guys. There we go. This is a spanning tree, as you can see right here in the wire short capture. It's saying this is a spanning tree protocol message right here. So it's sending on a datagram to say, hey, there's a topology change notification. It's talking about which switch is going to be the root bridge, it's going through all this conversation, right? So now we come back here and try to ping, see if spanning tree has converged. It has. So the network is calm. My CPU on my tower here, the fan was going crazy. I don't know if you could hear it, but it just calmed down. It's like all is well in the world again, right? So spanning tree can be a beast, but it can save your ass too. So yeah, let's take a look at spanning tree on the switches again, and we should see one of these ports is blocked on one of the switches. Yeah, I want to do a brief there, guys. Show spanning tree VLAN 10 brief. So switch 1's forwarding all packets on all interfaces, frames that is. Alright, same thing on switch 2. And we should now see that the port is blocked on switch 3. There you have it, guys. So fast 1-1, this guy here, it's like, think of it like a tree fell on that port and it blocked it. So that's why we're not having a loop anymore. So I hope this was helpful, guys. We broke down what a switching loop is, how it floods the network, what the symptoms are. So we talked about congestion, obviously, resource utilization on the switches. I've seen it bring switches to their knees and you had to go physically bounce the switch, or, you know, if you couldn't fix the loop, the switch, you couldn't get into it through anything. You'd console in and you'd basically have a dead switch. You'd hear it though, it'd be humming real loud because it's burning up. We also talked about the MAC address table flapping, so I think I'm learning it here, I think I'm learning it there, I think I'm learning it there, I think I'm losing my mind, basically, right? Because that's what the loop does. It's a bitch, it's crazy, it'll mess things up real quick. So if you don't know spanning tree, I would suggest at least learn the very basics of spanning tree, what it is, how we configure it, how to check with that show spanning tree VLAN, insert your VLAN number there, brief. That'll give you just the summary, what ports are involved with that VLAN spanning tree configuration, and then which ones are in a forwarding state versus a blocking state. So again, guys, hope this was helpful. Thanks for watching. Do me a favor, please hit that thumbs up and please subscribe. Till the next one, take care, guys.